My name is Alex Dworjan. I'm an Ansible solution specialist, and today I'm going to talk about Ansible execution environments to dive into what they are, how they work, and how you can ease some of the building process leveraging automation.
So, what are execution environments? Execution environments were introduced to the Automation Platform 2.0. And if you've ever used Ansible in the past, so Ansible 2.9 or older, you probably noticed that the number of modules included with Ansible was continuing to grow. From a management standpoint, if you've ever managed a single repository and had multiple people contributing updates and pull requests and issues, it becomes very, very difficult to manage, especially when I try to merge them in and 15 other changes have happened while someone was going off and doing changes on a particular branch. Also, from a usability standpoint, maybe I'm concerned about automating Microsoft Azure and a new module has come out. I actually had to upgrade the entirety of Ansible in order to take advantage of that module. So maybe I was operating on Ansible 2.9.10 and that module is included in Ansible 2.9.20. So while I could upgrade to 2.9.20 to take advantage of that new Azure module, I may also be upgrading other modules as part of that release. There is no way to independently upgrade modules based on what technology I was using in my environment. So by shifting to this idea of collections, which really was introduced with Ansible 2.9 and you can use in 2.9.10, and then became really the standard going forward for 2.10 and newer, I can now independently upgrade those pieces. So I can use the latest and greatest of the Microsoft Azure collection because the API of Azure changes quite often, while version locking other collections, such as maybe I'm using an older vSphere, I'm on 6.7 instead of 7.0, I can leverage some of those older collections. Also, as you look at consistency in your environment, well, maybe I've got a different development environment than I do my production environment running the automation platform. How do I ensure that where I'm developing my playbooks is running in that same environment that I've got in production? Do I have multiple Python virtual environments? Have I put in the exact same collection version, the exact same Python dependencies? I don't necessarily know. So with execution environments, now I have a portable way of creating automation. So in this execution environment, I've got the exact Ansible core version that I want, maybe 2.13.5, the specific collections and collection versions that I need. So maybe it's the latest Microsoft Azure collection, but the VMware collection 1.0.0. I've also got any Python dependencies that I need. And again, this is nicely independent of the system Python that's being leveraged. And also the beauty with Ansible Builder and how collections are maintained. Most of the collection maintainers have a requirement.txt within them, and that already lists out all the Python requirements, and that is automatically pulled in when I run Ansible Builder. So I don't have to keep track of all the different Python dependencies and versions. And again, if you leverage Microsoft Azure, you probably know they have a large number of Python dependencies that can change. Now I don't have to worry about maintaining them. Maybe I just have to worry about some specific filters that I leverage for Cisco devices or something like that. I can also add in system dependencies and then really anything else that I need to run a playbook. So you can be creative and add in Git capability if I want to do Git directly inside my execution environment. I can add in certificates for my particular environment, so I don't have to worry about that. You really can get very creative in terms of what an execution environment can contain. So as I start looking into a nice visual of what execution environment looks like, this is a nice way to think of how they are. So this is a portable, packaged way to maintain my Ansible usage. So I've got all the collections, libraries, and Ansible core sitting on a universal base image. Typically from Red Hat, we provide RHEL 8 as that base image, but this gives me that flexibility. So instead of every time I stand up a new Ansible development server or I try to shift things into production, having to reinstall all those collections and libraries and that exact Ansible version. Now I just have to copy that execution environment because it is essentially a container. I can just push that into a container registry, pull that leveraging something like Docker or Podman, and I'm off and running. We've also added in some tools like Ansible Navigator to run your playbooks in those execution environments. So I leverage that heavily today with my development server. I build my execution environments, push them into Private Automation Hub, and then leverage Ansible Navigator to test them, verify all my playbooks work, and then that exact same execution environment ends up in Automation Controller, so I know that what worked from the command line will absolutely work inside my automation platform. So building execution environments, because they're very difficult to use unless I build them. There are some base ones that exist that have some supported collections. There obviously are a min one, which is what we recommend that you build off of, but they are built leveraging the Ansible Builder tool. So this really lets you define all of the pieces of how you build your execution environment. Once that's done, I can push it to Private Automation Hub or really any container registry that exists. So if you already have Quay in your environment, you can push it to there. That's really up to you. Then I can test those execution environments using Ansible Navigator. And the nice thing about Ansible Navigator as well is it can also inspect your execution environments. So instead of in the past having to dig through file trees and find all the collections and exact versions, I can actually use that text user interface of Ansible Navigator to see exactly what collections are installed, the exact versions, the documents, what Python libraries installed, the system dependencies, and the exact versions of every single one of those pieces, and also run my playbooks through it. So it really gives you a very easy way to see exactly what's going on in your environment. Then I can run that exact same execution environment in Automation Controller. So I've got that consistency between my CLI testing and my actual production automation. This is a big difference that honestly I've greatly enjoyed because now I don't have to worry about making sure those two environments are exactly the same, or every time I updated a module or a collection in the past, sometimes those system dependencies or those Python libraries changed. Now that's included in that builder process. Because I like to leverage the latest and greatest in execution environments and collections, I actually have it scheduled in the automation platform to rebuild my execution environments every single week and push to my container registry. That may not work for you, but it gives you the idea of I can automatically build these pieces to keep them as up to date as needed for your particular environment. So now I want to jump into a demonstration to show how I build my execution environments so you can see what that capability can look like and how I can leverage Ansible to actually build these pieces for you. So if you've never built an execution environment before, it actually leverages the Ansible Builder command line utility. So I've got Ansible Builder running in this particular environment. I also have Podman running as the, in my case, container engine. So both those are running. And that's what I leverage to actually build my execution environments. Fortunately, Podman is also used by Ansible Navigator to inspect them. So at this point, I just want to walk through, at least from the command line, what Ansible Builder uses. So the main part is that execution environment.yaml, which defines how I go through my process of building my execution environment. So this includes the base image, so I need some sort of base image to build off of, and a builder image. I'll paste a blog in the description that will walk through a little bit more about the anatomy of an execution environment that kind of talks why this process exists. But this is what I leverage for the existing containers to build off of. I also have an Ansible.config, and this basically sets up how I pull from either Galaxy, Public Automation Hub, or my Private Automation Hub. And then I've got the dependencies that I actually want to leverage. So these are all my collections. These are all my additional Python requirements. These are all my system requirements. And then I can add in additional build steps. So I go through the process of adding in my certificates that I use in my end systems. I actually also set up Git so I can run Git inside my execution environment to pull and push directly from my execution environment. And then I've also got some other things set up where I leverage Terraform inside my execution environment. But again, it gives you a lot of flexibility in terms of what you do to create your execution environment. So next I want to dive into that requirements.yaml. So this is where I maintain my list of collections that I leverage. As you can see, I have quite a few. You can split these up and have as many execution environments as you want. There really is no requirement to have this many single execution environment. But as you can see, I can add in a version lock for specific collections. So for me, I am limited to vSphere 6.7 currently in my environment. So I version locked the VMware REST collection to 1.0.1, while everything else will leverage the latest version of those collections. So this does give you that flexibility to ensure that I won't upgrade every time if I don't want to, but in this case, I do, for my environment, want those latest collections. As you can imagine, with this many different collections, I would probably have a ton of Python requirements that are needed. If you've ever worked, again, with Python requirements in the past for Ansible modules, I would expect a lot to exist. I have 3. So these are actually all related to some of the Cisco work that I do to make sure I can run some of my Cisco modules to push new firmware or run filters based on some of the input that comes back. Well, I don't have it for anything else that exists. So this really leverages that ability of push the requirements to the collection maintainers rather than the end users. So again, this has simplified a lot of the process for me. And then I do have that binddep.txt just to add some additional pieces in there. The first two are just ones that I use as an example, and then I've got Git, because I did mention that I run Git in my execution environment. Then from the command line, all that I would do would be Ansible builder, build, and then I would give it some sort of name that I wanted for my container. So all of mine are named Shadowman EE, because that's the environment that I leverage. So what if I actually want to do this through automation rather than doing this through a command line interface? I can actually create playbooks for that process. So obviously all of my execution environments live in, for me, Private Automation Hub. That's also where all of my collections live. I don't pull from the public internet for anything. So first off, obviously, this is my Private Automation Hub. As you can see, I sync a lot of remote repos, and also I have my existing execution environment that I leverage, that I push all my different versions, one that I pushed 5 days ago, and then I also have all the collections that I leverage in here. So if you've ever used Private Automation Hub before, it doesn't automatically pull down content. I do have to sync the repositories that exist. So I have to sync either the community repository if there's some upstream collections that you leverage, as well as the Red Hat certified repository if you want to leverage those. So obviously I could manually come in and do that each week, or again, this is where I leverage the beauty of automation. So jumping into my environment, I actually do leverage Ansible to run this process. So rather than just doing this from scratch, I do have a playbook that syncs all of my Private Automation Hub remote repos. Very simple, where it essentially leverages that API to sync the Red Hat certified, make sure that it's completed before it moves on, syncs the community repo, and then moves on. So if you're not using Private Automation Hub, or for whatever reason, I could basically just take this particular playbook and remove that section, just go right into building your new execution environment. And then for the actual building EE role, this is where I go through the process of actually doing everything necessary to create an execution environment. So I pull in those two builder images that we talked about before, so that base image and the builder image. I like to delete my old execution environment just so I don't have it lingering around. And then I actually template out the builder files. So all those files that I walked through before are actually leveraging Jinja templates to create based on a definition file that I have. So I don't have to manually log in and make these changes. I actually have a version control history of all of these files for me. And for my Ansible.config, I actually leverage variables or credentials that I have stored in Automation Hub and Automation Platform, so I don't have to worry about maintaining that direct link. I'll talk about those in a second. Then I actually go through the process of building that execution environment, so using Ansible Builder. I also like to prune all the extra images so there's no random containers that are hanging around. And as you start looking at supply chain, I actually have a Galaxy keyring set up that I have set on this Ansible dev server that's already there, so that's not part of this build process, but I've created a Galaxy keyring that includes my signature as well as the Red Hat signature, so I can verify before I build that I've got full supply chain custody between the collections coming from Red Hat as well as the collections that I've created. Then I actually reach out to Private Automation Hub to get the tags, because I want to make sure I'm creating the correct tag versions as I go through this. And then I basically just do some figuring out to determine what the latest tag is, and then I do a simple increment to create that new tag in the execution environment, push it to my container registry, which for me is Private Automation Hub. I do some simple removing that tag because I just keep latest on my Ansible development server, and then I actually update in Automation Controller with that new version. So obviously when I'm running these playbooks, I do want to leverage that current execution environment. So this is one of the things that you'll learn as you start playing around with execution environments more. By default, many of your execution environments have the latest tag. It is not doing a comparison of the digest to see if there is a new latest version that's out there. That's not how container technology works. So it's just going to see, do I have an image stored locally that has this exact name? The answer would be yes, no matter if it is an older version of that execution environment or not. So that's why I shifted to leveraging this capability. So I've got the actual number of the execution environment as I go through this. So this is the one that I push and update on a regular basis. So as you can see, I'm on the 6.3 is my latest version. So when I run this on Saturday, it'll actually update to 6.4. And the next time I run a playbook, it will pull that version because it's not stored locally. And based on how containers work, it actually will delete the old cached execution environment. So the 6.3 one will disappear from all of my controller instances, and it will be replaced by 6.4. That's another issue if I use latest and I just force it to pull. So obviously I can change the pull to be always pull to pull down the latest one. It'll then have some of those just legacy images sitting there that will have a none tag and be taking up space. By leveraging the image tag number, it actually will clean that up for me, and that's just built into Podman and Docker is how that capability is leveraged. So I did want to dive into then the specifics of, well, how am I doing this templating? So this templating, I actually have in my repository a defaults file with my main.yaml, and this points to everything that I use to build out my image. So this has the specifics of what the directory is that I'm doing my build, my private automation hub server name, what I want to name my execution environment, the file names. For some reason I decided I don't want to use bindep or requirements.txt. I've got that flexibility. The specific images that I'm building off of, my Ansible config file. I even have my Galaxy keyring that I leveraged, as I talked about before. And then this is where I actually define each of those individual pieces. So those bindep files, my Python requirements, all of my collections, any of those append and prepend steps, all of those are included there. And then I leverage Jinja to build that out. So while this may look complicated, just know that this is taking what's in this file to build out my execution environment.yaml. And I have the same thing then for the requirements.txt for Python dependencies, the same thing for collections, the same thing for the Ansible config. As you can see, I leverage this credential that I have in Automation Controller to update the URL and token, so I don't have to store that anywhere. And then I do the same thing for the bindep.txt. So this entire process is automated. The one thing I will note that if you've noticed, I do leverage collections in my building execution environment.yaml. So I leverage the containers.podman collection, and I leverage the Ansible.controller collection. So the execution environment that I am using to build has both of those collections in it. That's it. Make sure when you're trying to do this that you're not trying to update the collection that you're building the execution environment with. It will kind of break things in controller, but it obviously would still work. So if I'm doing this from the command line and I'm not trying to leverage this to Automation Controller, I can remove this step. And obviously, if I don't have Private Automation Hub, I can remove the step where I'm pushing the execution environment. So this really gives you the flexibility to do this entire process in Automation Controller, Private Automation Hub, or just directly in the CLI to build out these pieces. So as I kind of talked about, I've got this 6.3 execution environment that exists. Well, I wonder what's contained in it. In the past, I'd actually have to dig through the individual file trees to try to figure out what Python libraries are there, activate different virtual environments, figure out what collections are there. Not necessarily the easiest process. So Ansible Navigator is a new tool that lets you run playbooks in your execution environments, but also lets you inspect your execution environments. So I just have here an Ansible Navigator definition file that basically says, leverage Podman, leverage that execution environment, and here's my directory that runs everything. That's about it. But if I actually run Ansible Navigator, it will pull up a text user interface that lets you inspect some of the things that are going on in your environment, or obviously running playbooks. I won't be running a playbook for this particular instance, but I'm going to inspect that image that I have. I've got the supported one that Red Hat provides, but I do have my Shadowman EE execution environment that I'll dive into that I built earlier this week. So I can look in here and see, well, there's a lot of different information. Maybe I only care about what Ansible version is there as well as the collections in their versions. So I'm just going to hit 2, and that will dive into the specifics of my execution environment without digging through the file trees on a RHEL server or anything like that. So this will actually pull up and show me that I'm running on Ansible 2.13.6 and the exact collection versions for each of the collections that I've added in. You'll notice that VMware collection is that 1.0.1 that I had version tagged, but all the other ones are the latest at this build time. As I also talked about, Python dependencies. If you remember my requirement.txt, I had 3 listed. If I jump into the Python dependency section, I have significantly more than that. So you'll notice all of the Azure Python requirements that are here. I didn't list any of them, but they were automatically pulled in as part of that build process. And now I have 212 different Python libraries that have been added in. Some are part of that base image. Some are part of pulling in those specific collection requirements for all the individual collections that I leveraged, like the vSphere Automation SDK. And then I can also dive into the system dependencies to see all of those that were added in as part of this installation. So again, all of these are running in my execution environment, not on my actual file systems. So this makes it much more transferable, and I don't have to worry about what Python is running on my system. Now it's all contained within that execution environment. So it gives you a lot more flexibility in terms of what you're doing and running your automation. And now I can actually run my playbooks using Ansible Navigator, using Automation Controller to pull from my container registry that is all of this maintained for me. So I can have this streamlined process to really build, run, test, and then push into production my entire automation container process. And then obviously you can leverage those execution environments to build off of, to use your playbook leverages using something like VS Code and the Ansible extension to help with some of your playbook development. So it really gives you a lot of flexibility as you start building and testing these things out. So where can you go next? As I mentioned earlier, there's a blog that walks through the anatomy of an execution environment so you can really see what's contained in there. That'll be down in the description below, as well as one of our marketing managers actually walk through building out execution environments using GitHub Actions. So if you want to use that as a different way to trigger it rather than automation platform or manually triggering them, this gives you that flexibility as well. So personally, I just have mine scheduled again in the automation platform and just have that, in my case, run weekly to build out those new execution environments. So this is a new way to make those development environments available for you whenever you need them and very transferable as you go through this process. So I appreciate everyone taking the time out to learn a little bit more about execution environments and how I build them. I hope this is helpful as you start looking into the new automation platform and how you can streamline some of your processes and reduce some of the work that used to be required to keep up to date with the latest modules and collections. Thank you.